All right, so this is 7.6 part 2. In case of yesterday, we were talking about complex numbers, and complex numbers were just, well, not complex, it was just the imaginary part. So we were talking about like the square root of like -16, and that was just 4. Because we would break it apart into the square root of -1 times the square root of 16. Okay, so now when you see this stuff, like you should be pretty good with it. You guys should be like to the point where Justin, like when I'm talking about the square root of a negative number, like you shouldn't have to break it apart. You should just know that the square root of -16 is just going to be like 4 off. You okay with that, Lance? Now there's one more thing from this. It's a complex number. So a complex number involves a real number and a
It counts. It counts. It wrote stuff.
I don't know. I don't think it counts.
You need to write.
Alright.
You need to write the equation.
Yeah, you gotta make it through the whole class.
The whole class. That's not. That's.
There's a pencil right there. But Jake, remember, this is being recorded, so we're gonna know. So there's 2 parts to a complex number. There's the real part, and then there's the imaginary part. So let me break this down for you. A complex number, Justin. No, it's all good. A complex number has 2 parts. We write them as a plus bi. A is your real number, and b is your complex number. Okay, so it's going to be written as a plus bi. Now on your web assignment, it's going to give you something, and it's going to be like, okay, what is the real part and what is the complex part? And it's pretty simple. The real part is the part without an I, and the complex part is the part with the I, or the imaginary part. Make sense? So up here it says find the values of x and y to make the following statement true. So it has 3x minus the square root of -25 equals -6 plus 3yi. Now with these, it's not as difficult as it seems because you have 2 parts. You have a real part and an imaginary part. So what we need to do is we need to make the left side kind of broken down and simpler. So we have 3x. Nothing I can do to break that down. But Leah, do you see how I have the square root of -25? What is the square root of -25? So I'm just going to write it as 5i. So the left side is written as 3x minus 5i. And this right side is -6 plus 3y. Do you see that, Leah? Now, we have 2 parts. We have the real part and we have the imaginary part. And all we do is we are going to set the real part to the real part. 3x equals -6. What would x be, Leah? -2. And now we have the imaginary part, Julia, and the imaginary part. So when I'm doing this, okay, little trick is I don't really need the I, right? Okay, because I already know it's the imaginary part. So I just have -5 equals 3y. Julia, what would y be? -5 seconds. All right. Jerry, are you okay with this?
Like -6 plus my eyes, but there's no I.
All right, let me explain it one more time, and then let's see if it clears up your question. All right. So with complex numbers, we have a real part, which is the I. It's the part without the I. And then we have the imaginary part, which is the part with the I. Okay. And when we're being asked to, like, I guess, kind of evaluate or find the value of x or y in question number 1 here, what I'm going to do is I'm going to break both sides down as far as I can go. The right side I have -6 plus 3yi. there's nothing I can really break down, correct? But on the left side, notice I can break down the square root of negative 25 further. So I did that. Leah told us it was
Yeah.
5i. Now, from here, my number or my expression has two parts. It has the real part, which is the part without the I. So the real part must equal the real part. Okay? So 3x must equal negative 6. That's why I wrote it in green. You see that? And then I solve for that. There is no I with that at all. But now when I move to the imaginary part, right? I have negative 5i must be equal to the 3yi. But what I was telling Julia is we don't really need to incorporate that I into our like expression that we're solving because we already know it's the imaginary part. The green was the real part and the red was the imaginary part. So I've kind of already dictated that that's going to be my imaginary, numbers or section. Does that make sense?
Yeah.
And then I just solve it. If I put the I in there, am I wrong? No, but I think it just complicates things more, right? Because now I have negative 5i equals 3yi. And now it kind of looks like I have two different variables. And that I feel just confuses kids. Okay? Lance, are you good? All right.
So two different things you do.
Two different things. All right. Now, adding, subtracting, and multiplying complex numbers. My answer is always going to look like this, Jay. Some real number, A, plus BI. I'm going to have something with I's and without I's. That's it. Okay? So I'm going to try and make this look like that. So what I do in number one is I just treat this like a normal problem and I distribute that 5i. I'm not really worried about it too much right now. So 5 times negative 2 is negative 10, so negative 10i. 5i times I, well, that's going to be plus 5i squared. Justin, you good? Mike, you okay? Lance, you okay?
Yeah.
Franklin, at home, you okay?
Yeah.
Now the problem is, this does not look like this, does it? Because I have I and I squared. But if you turn to the front or the start of 7, 6, there was two things I wrote at the top. It was I equal to the square root of negative 1, right? Does everybody see that? Below that, it says I squared equals negative 1, correct? So up here, instead of, I'm going to write that right there. I squared equals negative 1. So instead of writing I squared, I'm going to write negative 10i plus 5 times negative 1. Now this looks more like a plus bi. So my answer would be negative 5 minus 10i. Does everybody see that? You okay with that? Now the question becomes, well, what if I had I to like a higher power? Okay. What if instead of I squared, I had I cubed? Okay. Well, if I had something like, I cubed, I would just think about this one. I equals the square root of negative 1. I squared, right, equals negative 1, right? Well, what would I cubed be? I cubed would be I times I squared, right? So the square root of negative 1 times that, it would be negative square root of negative 1. All right. What would I to the fourth be? Well, that's I squared times I squared, right? So it's negative 1 times negative 1. That's 1. And here's the cool thing about I. Guess what? I to the fifth Well, guess what? That's I to the fourth times I. So it goes back. It starts repeating. Now, over here, the way I write it is I don't really write a ton of stuff like this over here. Okay. I'll typically refer to these as, you know, we have I. I'll show you. We have I squared, all right? I squared equals -1. I keep that in my back pocket. All right, Lance? I cubed is equal to -I. I'll show you. And then I to the fourth is equal to 1. Now, Justin, you're like wondering, how is I cubed equal to -I, right? Well, we talked about I squared, right, is -1, right? I multiply these two together, right? Well, isn't I squared -1? So what's I times -1? -I. See that? So I's are kind of like cyclical, meaning it's only got like, once I hit a power greater than 4, it just goes back through. It just cycles back through. Okay. So like 5, how many times does 4 go into 5? 1 time with how much left over? 1. So I to the 5th is just I. Okay. Like if I said I to the 77th, you do 77 divided by 4. Okay. You get some number, right? We discard that and we only look at the remainder. So how many times is 4 go into 77? Well, 4 goes into 7 one time, one time with 3 left over. So we have 34. How many times does 4 go into 34? 8 times with 2 left over, right? Or 77, no, it was 37. So it'd be 1 left over. So it would behave the same way as I.
So it'd be 9.
It would just be I. I to the 77th and I to the 1st are the same. All right. So up here, number 2, we're going to FOIL this out. So we do 2 times -6 is -12. 2 times -2i is -4i. 3i times -6 is -18i. And 3i times -2i, that's going to be -6i squared. Don't forget, we have I squared equals -1. So now we combine these two in the middle. So we have -12 minus 22i minus 6, and I squared is -1. So we're just going to combine our two numbers here, -12 and +6. So that's going to be -6 minus 22. Jake, you okay with that? You okay with that?
I think so.
All right. Hannah, you feeling all right? I know you just got done. You can just veg out if you want. But you can watch this later because we don't have a website tomorrow. All right. You can just soak it in and just chill. All right. So up here for number 3, the only thing I have to distribute, Jay, is that -1 in front. You see that? See how it says 6 minus? Yeah, so I'm just going to change the signs, right? So minus the -2, that's +2, minus the +9 is -9. See how I got that? And now I group all my i's together. These two come together to give me -5i And all three of those come together to give me 0. My answer is just -5 pi. Julie, are you okay with these so far? 1 plus I squared. So we have 1 plus I times 1 plus I. Just going to distribute this out. We have 1 plus I plus I plus I squared. So far, so good. So we have 1 plus 2I, and then I squared is -1. So to put that in, so I have 1 minus 1, they cancel. The answer is just 2I. Isaac, you doing all right? I'm not stressing you out too much. I know you have a test later too, so you need a break, just let me know.
So you graph those two out.
Yep. Now, Justin, these are the last 5 questions, right? There's no more? Okay. So simplify the following. Complex numbers behave just like the radicals. When I asked you, I guess on the last test to like multiply by the conjugate and stuff like that, same thing here, okay? So let's start with number 2, okay? I can't have an I in the denominator because remember, I is the square root of -1, so I can't have that. So what I do with number 2 is I multiply by the conjugate. The conjugate of 4 minus I is simply 4 plus I. All right. Now, the real difficult part of this problem is actually multiplying the bottom, okay? Because we have to, I guess, kind of FOIL that out. So we have 4 minus I times 4 plus I. 4 times 4 is 16. 4 times I is 4I. And Jay, do you remember what happened when we multiplied the conjugates together with the radicals? What happened to the middle? Middle cancel. Watch what happens here. I times -I times 4 is -4I. -I times I is -I squared. Jay, do you see how the middle still cancels here? And Jay, do you recall what I squared is? I squared was, so it's 16 minus -1. So we have 17. In the numerator, 7 times 4 is 28. 7 times I, 7I. Done. Okay? You good? Lance, we okay? Amelia, we okay? All right,
So where do you get 27 from?
7 times 4.
Oh.
All right, number 3, we're going to multiply by 1 plus 2I. 1 plus 2I. A little bit more work with number 3 because we're going to have to FOIL out the numerator as well. All right. So 5 plus 3I times 1 plus 2I. 5 plus 10I plus 3I plus 6I squared. So 10I and 3I is 13I. I always know your voice. And then we have 5 plus, why don't you guys just chill and relax and just watch? Okay, you don't even have to get out your book, just chill. So we have 5 plus 13I, and then Jay told me I squared is -1, so 6 times -1 is -6. So this will be 5 minus 6, that's -1. How's it going? Kaylee, you can just chill and relax, decompress. And then we have 13i in the middle. Oops, sorry, that goes up top. Thank you. All right, on bottom, we had 1 minus 2i times 1 plus 2i. We FOIL that out, we have 1 plus 2i minus 2i minus 4i squared. 2i and minus 2i, they cancel. So I have 1. And then I squared is -1. So we're going to have 1 minus 4 times -1. Well, -4 times -1 is +4. So we simply get -1 plus 13i over 5. Yeah. Yeah. You okay with that? Lance, still doing all right? Julia, you still doing okay? Yeah. All right. Now that we've done all of that, let's go look at number 1. All right, number 1, it's not that I was skipping it. I just thought it was easier to start with number 2 and then reinforce it with number 3. The conjugate of I is simply itself. All right, we just can't have I in the denominator. So we're going to multiply it by itself here. Seems kind of weird. But remember, the whole goal is to have the denominator be a number and not something with a square root. So here, this is just 5i. And then the denominator, it's I squared. And Jay told me I squared is -1. So this is just -5i. Do you see that, Jay? Last but not least, number 4. You're going to multiply by 1 minus I and 1 minus I. I'll give you a second to see if you can get the answer. And then I'll put it up. Justin, you got it? Yeah, that pencil doesn't count, bro.
Yes, it does.
No.
Yes.
You, what's in that? Yeah, but
Yes, it does if it's great stuff in it.
no, that doesn't count. You don't need 50 push-ups.
No, I don't.
You do.
It was 10 push-ups.
I'll email him to mom.
Huh?
I'll email him to mom.
It was 10 push-ups.
All right. It goes more than that. All right. Julie, did you FOIL the denominator? Did you get 2? Now I know why you got 0 because you forgot. It's I times -I. So it would be -I squared, correct? And this is the number 1 issue, is that people will drop one of the negatives because there's so many negatives now with I. So it's going to be 1 minus I squared. I squared is -1, so it's 1 minus -1, which is 2. Do you see that?
Yeah.
Did you get the numerator? I didn't get it yet, so hold on. You did? Okay, see if you can get the numerator. See. See if you can get that. You don't know how I got it? 2 times 1. So let's write it out. I mean, I could be wrong. 2 times 1, 2. 2 times negative I, negative 2I. Good so far?
Yeah, I think I wrote the eyes.
Oh, yeah. Negative 7I times 1, negative 7I. That looks good for my answer because that's going to come out to be negative 9I. And then here's going to be plus 7I squared. I squared is negative 1, so it's going to be 2 minus 7, which is negative 5. All right. All right. Show that x equals 2 plus I is the solution of the equation x squared minus 4x plus 5. Any ideas how to do this? Leah's like, nope, not a clue. All right. One thing you could do, Leah, is you could just plug it in. Okay, plug it in. So 2 plus I squared minus 4 times 2 plus I plus 5. And I am asking, does it equal 0? Okay. If I FOIL this out, it's 2 plus I times 2 plus I. Distribute this. It's negative 8 plus or minus 4I plus 5. Again, I'm still asking, does that equal 0? Not to a point yet where I can say it definitely equals 0. 2 times 2, hey John, it's 4. 2 times I is 2I. I times 2 is 2I. I times I is I squared, or negative 1. Minus 8 minus 4I plus 5 equals 0. Still asking. Okay. Now, negative 4I, and those two cancel out. And I have 4 minus 1 minus 8 plus 5. Does that equal 0? I think it does. And that's the one.